Okay, so now let's talk about the fuel system. So I brought up the 208's fuel tank system on the POH. You're really going to need the POH or some diagram to help you here because you need to know how the tanks are, what type of tanks it has, as well as how big they are. So the fuel system on the Caravan is relatively simple. We got two tanks, one on the left, one on the right, that feed a reservoir that feed into the engine. Now, real quick, let's look at the Super King Air. This is the Beech 200's fuel tank layout. Now, it has several different tanks. It has a leading edge tank, two leading edge tanks, an integral wet wing tank, and a box section. Each one of these is a different tank, and these tanks together, you don't really have a way of defining each individual one in the sim because you're really limited. This is one section where the sim could use some improvement. Here's the only tanks you can have. You can have 3 center tanks, 3 left tanks, 3 right tanks, and 2 external tanks. So center 1, 2, and 3 are your 3 center tanks that you can have. You can have a left main tank and a right main tank, a left auxiliary tank and a right auxiliary tank, and a left tip tank and a right tip tank, plus 2 external tanks. Now, I don't know, the SDK doesn't really tell me how the sim works in terms of which one feeds the engine, which one feeds another tank. Presumably, an external tank feeds one of these tanks or something. I'm not 100% sure. But that's usually... Because let me just look at the King Airs. You would combine these 4 separate tanks here into the one big tank for the left tank. And then this would be your auxiliary tank. Most engines also have a sort of a reservoir tank, a small one that holds fuel before it gets fed into the engine, and you can see that going on with the King Air. Both the left and the auxiliary tank feed this secondary tank in the engine nacelle that feeds the engine. And you see the same thing on the Caravan here. We have the 2 tanks feeding a reservoir before it feeds the engine. I don't know for sure, but I'd imagine Flight Sim probably replicates the reservoir by itself. Actually, I know it doesn't. It just knows which tank feeds the engine. And unfortunately, that seems to be handled by the sim itself, or it might be defined in the air file. The one thing I know about the fuel system that is defined in the air file is the fuel's weight per gallon. That is handled by the air file. So real quick, let's go over the Caravan here. You enter the name of the tank you want, which is any one of these. So we got a left main and a right main. And then you enter its position data, longitudinal, lateral, vertical, just like before. Then you got 2 extra numbers. These are the fuel tank's capacity in gallons. And actually, no, wait. Both of them together form the capacity. So 166.0 plus 3.6. That means we have a 169.6 gallon tank is the left main tank. Now, why are there 2 numbers? Well, the first one is the usable amount of fuel, and the second one is the unusable. All aircraft fuel tanks naturally have a certain amount of fuel that's unusable. And that's actually factored into the aircraft's empty weight sometimes. But here it needs to know exactly how much gallons it can't touch. It's usually pretty small. So like the Cessna Skyhawk, for example, had like 2.5 to 3 gallons unusable usually out of a 56 gallon tank, and the two together, you had 56 gallons total in the Skyhawk, but only 53 of which were usable. So you had about 3 gallons total that were unusable, 2.5 for each tank. So you get it there. And you just repeat that for each engine. So if we look back at our wireframe model, you see these 2 blocks here and here. These actually define the positions of the fuel tanks that show us right here on the model. And you can see they're not in the right position on the Caravan. They seem to be pretty correct laterally, or no, longitudinally, but laterally they need some work. So vertical and longitudinal is fine, but we need to move these out. Let's move them out about 3 feet. So increase both of these to about 4.1. It's just like working with the weight and balance data like before. So we've moved them out laterally, by 3 feet. Let's reload our model and see where that puts them. Well, needs a little bit more work. So they're right about here. Switch to texture. Where's the filler cap? The filler cap's right here. So we know that the wing tanks on the Caravan are pretty big. If the filler cap's right here, they probably need to be moved out to roughly halfway down the wing. So let's move them out that far, another 3 feet. 1, 2, 3, 7. So let's put them out both to 7 point. I'm actually going to put them to 7.5. And this is just like with the weight and balance data. I want to get these positioned right where they are, where they should be on the visual model. So let's close that and reopen. So that looks a little bit better. Filler cap's right here. So I'm going to push them out a little bit further. I'm actually going to bring them forward some too. Let's move these to 16.5. And move them out another 1.5 feet. So let's say that'd be 1 foot. Let's go with 9.0. Same on here, 9.0. Save. And reload. That looks much better. That's right about where they should be. So you saw before the default Caravan had its fuel tanks over here, which is not where they are, especially if you look at the 3D model and see the filler caps right here. So they'd be moved closer to or further out from the fuselage. Now we got them in about the right position. And you can look on your POH and kind of tell, it should tell you about where they are, or at least where their arm is on the weight and balance data. So that is that. Now there are other things we need to enter here. Fuel type. This is the type of fuel it has. It's either a 1 or a 2. 1 is avgas, 2 is Jet A. Now one curious thing here is this does not match the scenery. If you look at scenery design, especially my ADE series, you may have noticed that fuel parking spots and fuel triggers can actually have many different types of fuel. Not just 100 low lead, but also 75, 85, as well as many different grades of jet fuel, and even MO gas is an option. Curiously enough, that's not replicated in the CFG file. It's either 100 low lead, which is avgas, or Jet A. So there's definitely one area of the sim that needs improvement. It doesn't make much sense that you can only have 2 types here, but the scenery side can have many different fuel types. So I don't know what's going on there. Now, number of tank selectors. The default Caravan only has 1 fuel tank selector. Whether or not it's a on or off selector or selects which tank to feed from is decided by the gauge itself. But here you can decide how many fuel tank selectors it has. Realistically, a Caravan has 2 fuel tank selectors, but the default only has 1. Now, this is the electric boost pump. This is just a flag, either a 1 for yes and 0 for no. Is there an electric boost pump available? Now, the boost pump can be used as either an electric backup pump or as a boost pump, how a boost pump normally is, to boost the pressure to make up for engine not being able to reach it to the next pressure. Fuel dump rate, this is the amount of fuel in percent per second that the dump system can have. Set that to 0 for no dump system on the plane. Control-Shift-D is the default key command to activate the fuel dump system, and it can also be activated by gauges. So make sure you set that. If you don't want the plane to have a fuel dump system, define it as 0. Now, these next 3 are just flags. Is there an engine-driven fuel pump? Either 1 for yes, 0 for no. Is there a manual transfer pump? Is 1 for yes, 0 for no. And the last one we have anemometer. Is there an anemometer pump? Now remember our anemometer we defined up in the systems that tells you the wind. This can also, an anemometer can also be used to run a pump. So particularly something like a ram air turbine would be like that, an anemometer pump. And 1 for yes, 0 for no. And that's the fuel system. So it's basically just like the weight and balance, longitudinal, lateral, vertical, Gallons usable, gallons not usable. The two together equal your total gallons the tank can hold. Make sure that is in gallons, not pounds, not kilograms, gallons. Complain about it all you want. It's really easy to convert these days. Just Google it. And that is the fuel tank system. So next we'll talk about instruments. Alrighty, so this part's going to be pretty quick. We're just going to talk about the instruments. Some instruments can have some things defined about them in the aircraft CFG file. To help us out, I brought up FS Panel Studio, and we're going to be using it to go over a few of these. So firstly, we have the direction indicators, and this is by far the biggest sin for this particular part of the CFG file committed by add-on developers. My first review for FS Elite was the Just Flight Cicada TB10 TB20, and that plane scored average. And one of the reasons it scored so low for me was because the gyro in that plane drifted, but it was not the type of gyro that should drift. It's the type of gyro that should be slaved to the magnetic compass and not drift. And the reason why is because Just Flight failed to put this in there correctly. So directional indicator 0 equals 3, 0. What does that mean? Well, for one, you can have multiple direction indicators in the plane. Just like that. You can have multiple directional indicators. And then you define the type, and the second number refers to which directional indicator it's slaved to, which only applies to a type of 4. So let's go over them real quick. Type 0 is none. This is important. Remember the defaults that I said would happen if you don't define things? Default is vacuum gyro. So if you don't define the directional indicator, Flight Sim will assume it is a vacuum gyro, which means the vacuum system needs to be working in order for it to work. However, that doesn't apply for all of them. So not all planes have a DG, so you have to actually say there's not a DG. If you put the type as 1, it's a vacuum gyro, which means the vacuum system needs to be working, requiring either an engine-driven vacuum pump or an electric backup vacuum pump. And vacuum gyros will drift. They drift a few degrees per 15. You have to reset them every 15 minutes, but they drift of about a degree or so every couple minutes. So they will naturally drift over time. Now, remember you could slave, or you could set an autopilot to reference a particular gyro? Some airplanes have their gauges set to match magnetic heading all the time. So the Coronado Skyhawk G1000 that came out recently, at least at time of recording, was like that. Its HSI will always match magnetic north. It's always correct, basically. However, the autopilot wouldn't fly the correct headings all the time, and the reason was the autopilot was referencing one of the directional indicators, and Coronado didn't set that number correctly. So for a normal default Cessna, it would be a vacuum gyro, but in the case of the G1000, that pulls from what's called a magnetometer. It actually pulls from the AHAR system, and the AHAR system gets it from a magnetometer, which the closest thing to a magnetometer in Flight Sim would be a Type 3, which we'll go over in a second. So vacuum gyros drift, know that. Electric gyros, they drift as well. The functionally 1 and 2 are the same, except the power needed to drive it is different. So a Type 1 needs a functioning vacuum system, but Type 2 needs electric power. And remember, we defined that in the electrical system. The directional indicator equals plus all that electrical info. And we can also drive the slaving. That comes in with Type 3, which is an electromag slave compass, functionally the same as Type 2. It requires electricity to work. However, it's slave to the magnetic compass, meaning it will indicate whatever the magnetic compass indicates. So that's very, very important. That's what you need to enter if you don't want the gyro to drift. Okay? Types 1 and 2 drift. Types 3 do not drift. So that's where you need to set it. If you have a gyro in any plane that's drifting, or an autopilot failing to maintain a heading on a gyro that's not drifting, this is what you need to come look at. Type 3 if you don't want it to drift. Now, if you have a modern plane that's pulling, that would normally come from an AHARS, There's no AHRS in Flight Sim. Hello, Dovetail and Lockheed. There's no AHRS in Flight Sim, so the closest thing you can do is the MagSlave gyro. Now, this does mean two things. One, note that in the electrical system, we define both the directional indicators power requirements and the slaving mechanisms power requirements. Both of those components can fail, so the slaving component could fail, or the gyro itself could fail, and on a Type 3, the magnetic compass can also fail. And since this thing will always indicate what the magnetic compass indicates, if the mag compass fails, so does the DG. Now, in real life, directional indicators that are slaved to the magnetic compass usually have a way to turn off the slaving so that they functionally become a free turning DG, where you can actually set the heading, but they don't drift and they free turn with you. The A2A 182 and the Gates Learjet from FlySimware allowed you to actually do that. You could turn off slaving and set that thing wherever. Unfortunately, that's not replicated in Flight Sim, sadly, at least not on the default level. Now, Type 4 is slaved to another. So, I entered in 2 more DGs here, and the reason is I wanted to show you something. If we set our second DG to be a Type 4, the second number comes into play now. You would set this to 0 for all of the types except the Type 4. And basically, this second number refers to which DG do you want a slave to another DG to be set for. So I've set DG1 to be slave to another, and the second number is 0. I've set DG1 to be slave to DG0. So DG1 will indicate whatever DG0 indicates, and DG0 is slave to the magnetic compass, so it will indicate what the mag compass indicates. And we can also define a backup gyro that has a vacuum system. And that's how that works. You can define multiple vacuums on the same plane. You can have more than one vacuum. So in this setup, we have the primary vacuum indicator, which would or the primary DG, which would be this thing right here. It's slaved to the mag compass. We have a second one, which would probably be on the co-pilot side, slaved to the first one, so it will indicate, that way the co-pilot and the pilots always match up. And then we have a secondary one, which would be our standby, and that is on its own vacuum system. That's how that works. So, messages to Dovetail and Lockheed. Where this needs improvement is we need more DG types. It stops at slave to another. What we could see, what I would like to see in the future, would be more types that we can use. Type 5 could be magnetometer, which is what your cell phone actually. Magnetometers are pretty small these days, and I believe a lot of cell phones actually have a magnetometer in them. That's how they get their direction info. Same in cars. They don't have a magnetic compass, they have a magnetometer. A Type 6 could be AHRS, which technically would be the same as magnetometer, but there is some differences between the two, because the way an AHRS system works is it uses a magnetometer to get the heading information, but this would come more into play for things like attitude indicators where alignments are required. And a Type 7 could be IRS/INS. That is... I'd like to see this improved in the future, okay? Because I don't like that it just stops at 4. Yes, we can make it work with Type 3, but it would be much, much better if you added these in the future. How do you add them? I don't know. Somewhere in the base code, the sim goes to look to find the parameters it needs. If it sees a 3, a 4, or a 1, or a 2 here, it's like, right, I need to look here to get the information on that. So just add to it, I guess. I'm not a programmer, so I don't know how difficult it would be, but that's how that works. Now, attitude indicators. Same as DGs, we can also have multiple attitude indicators, and we can define their types. Again, vacuum is the default. So if you don't have an attitude indicator, you actually need to specify that here with a 0 for none. So the Caravan has a Type 2, which is an electric gyro. And just like with the DGs, this defines what drives it. If it's vacuum, then the vacuum system drives it, and up here we defined what drives the vacuum system. As soon as I find it, where the heck is it? Here it is. We defined that our vacuum system is driven by an engine, or no, a pneumatic pump, so bleed air from the engine. So hopefully you're seeing how all this connects together. A vacuum system can be powered by a venturi tube, an engine pump, or bleed air, or the APU, which would be bleed air. So one of those needs to be functional, but you can also have a vacuum powered by an electric backup pump as well. So one of those things needs to be functional in order for a vacuum type gyro, which is your DG, attitude, and turn coordinator, to function. Now, the electric ones, on the other hand, just require electric power. But if that electric power is not available, they don't work. So that's how that works. And it's pretty much the same, except we don't have a second number to define. So if we want to have multiple attitude indicators, we just punch in a new one, make sure the number is increased, and define which one it is. So we could say the Caravan has an electric gyro, but maybe it has a vacuum gyro as a backup. And that's how that works. Pretty straightforward. Now, turn indicators, exactly the same as attitude indicators, I believe. There seems to be an extra number there, so let's look it up. That is labeled as, what is that labeled as? Turn indicators. There's extra number here too, but it doesn't tell us. Two code values which define the system on which the turn indicators are independent. First value is for turn, second is for bank. Alright, so this is for turn and bank here. So, which one drives which? The first number is for turn. The second number is for bank. So our turn indicator on the Caravan, if we look at it, is, where is it? It's right here. It actually does define turn and bank. It's sort of meshed into one gauge, though. So we have it set in the CG file for an electric gyro to define turn and no gyro for bank. So if we wanted the vacuum on the bank indication, that's how we do that. So just like attitude indicator, one is electric for electric power to work, and two is vacuum power to work. The big difference here is that the default is electric gyro. So if you don't define it, then it will default to an electric gyro, meaning it needs electricity to work. Lastly, we have airspeed indicators, and just like with the other ones, we can add more than one, but the big difference is these two numbers. There's not really a particular type of airspeed indicator. They all come from the pedostatic system. So what we're defining here, I believe, is the calibrated airspeed offsets. So if we look, first parameter is a scalar on calibrated airspeed, and the second is the offset in knots. The offset is applied first, then the scalar. The default value for this is scalar 1 and offset 0. Meaning that calibrated airspeed will be equal to indicated airspeed. So remember, there is a difference between calibrated and indicated airspeeds. What that difference is, you can look up. But most airspeed indicators in modern aircraft show you calibrated airspeed. Even if we refer to it as indicated, it is calibrated. Indicated airspeed is one thing. Calibrated airspeed is indicated but adjusted for errors in instrumentation. So here we define the difference. This is a scalar, this is the offset. So our first airspeed indicator has a minus 24.7 difference between calibrated and indicated at a scale of 1.183. So that means negative, let me clear, where's negative? Negative 24.75 multiplied by 1.183, that is the difference there. So calibrated airspeed is 29.2 knots less than indicated airspeed on this aircraft. And you would customize that for each individual airspeed indicator. Just remember that if you don't define this here, it will default to calibrated airspeed being the same as indicated airspeed. Now, the magnetic compass, unfortunately, is very limited. Though you can define things, there's really only one number you can enter here, and that's 1. You can define multiple magnetic compasses, it seems, but they all have to be the same type. A type 1, if I look it up, I believe that is no dip errors, basically. Set to 1 for vertical compass with no dip error. Now, I think Aces was planning on expanding that and just never got around to finishing it, so it's not a functional thing. But if these right here were all new features to FSX, by the way. These weren't in FS9, which is the main reason why you see add-on devs screwing this up, is because these were new to FSX. And add-on devs are really stuck in their ways these days. I'm convinced most of them didn't read the SDK. And that's why you continually see add-on devs, even the payware ones, screwing that up. And you saw how easy it was to correct, too. Like, just like Cicada TB10 scored low here because they had a 1 for a vacuum gyro for the DG, and it should have been a 3. So all you have to do to fix it is take the 30 seconds out of your life to change that number. And personally, I believe if you're going to be charging money for an add-on, the user shouldn't have to come do this. That is so piss easy that it's practically a sin that you didn't do that if you're a payware dev. Even freeware dev, look how easy it was to fix. Yeah. Anyway, with magnetic compass, I'm pretty sure they were going to add more. Since there's only 1, though, you can just put a 1 here, and that means it's a vertical compass with no dip errors. I'm curious if there is any remnants left in the code of other types that they planned on adding and just never finished. Like, maybe you can turn on or off dip errors or different types of compasses. I'm not sure. Anyway, that is the instruments. Now, hopefully, you are really starting to understand how these things sort of come together to make a functional aircraft now. How we specify that one instrument is powered by a particular system, we specify where that system gets its power, and then we specify how much power it takes to run it. So you're starting to see how everything connects together now. And that will continue. The next bit, we're going to start talking about visual effects. Then we're going to get into landing gear. So that's going to be fun. So stay tuned for that.